Good morning, friends. Last we discussed about the condition in terms of the path difference and phase difference for constructive interference and destructive interference. Now, due to the interference, which type of the pattern is shown on the screen? Which type of the pattern is shown in the on the screen? So here, now the pattern is shown like this on the screen. Here, the first is the bright line. Just above and below of this bright line, the dark fringes are obtained. Again, the bright fringes, again dark, again bright. So there is the bright fringes, and these are the dark fringes. That means the intensity is not shown. So due to the constructive interference, the bright fringes are obtained. And due to the destructive interference, this type of the dark fringes are obtained. Okay. So there is central bright fringes corresponding to the n is equal to 0. Either side of central bright fringes here. So these two are the dark fringes due to the first order of destructive interference. And similarly, these two bright fringes again, there is the due to the constructive interference. So here we are discussing about the interference, so that question arises in our mind that, so due to the interference, what is shown on the screen? So when the two sources or the waves produced from the two light sources and propagate in the medium during their propagation, when these two waves are superposed on each other, so a resultant pattern is formed like to this. Already we discussed about that, what are the waves generated in the water. Here the S1 and S2 are the two sources oscillating with the same phase. So here, what's happened? The first is the tug is produced when the both needle are going inside the water. When it comes out from the water, at the time the crest are formed. So there is the crest. Again the tug are formed. Again the crest. Again the tug. Due to this type of our wave pattern, these waves are propagated in the medium. During their propagation, the tug of one wave is superposed on tug of other, or the crest of the one wave is superposed on crest of other. So here the both crests are superposed. Here also the same way here. So corresponding to this line on the screen, this point is shown the bright. And the bright fringes is obtained. Corresponding to this point, the point at which the one tug is superposed on crest of the other, the same way. So here the dark fringes is obtained, or the dark spot is obtained. So here this bright spot or the bright fringes due to the constructive interference, and this dark point or the dark fringes due to the destructive interference. Clear this? So this type of the pattern is obtained on the screen. And we have the experience in our bathroom. So if the water is filled in one container and water is continuously increasing with help of a tap, at that time what's happened? The surface of the water is not the stationary, that is the oscillating about their mean position. At the same time, what are the wave of the light incident on this bucket of water? So at the bottom of the bucket, so this type of the fringes are obtained like this way. So actually that is due to the interference. That is due to the interference. Clear this? Okay. So this type of interference pattern is obtained in interference. Clear this? Okay. Now today we are going to discuss about what is the intensity at a point if the phase difference at this point between the two sources is phi. For that purpose, we assume that suppose the phase difference at point G between displacement of two sources, between the displacement of two sources is G. Right? Now, if the displacement of source S1 is Y1 is equal to A cos omega t, equation 1, and displacement of source S2 is given by Y2 is equal to A cos omega t plus phi. In equation 2 here we get the phi because the phase difference between these two waves or the displacement of these two sources is phi at given point Z. Right? Now, from principle of superposition, the resultant displacement at G is Y is equal to Y1 plus Y2. Before this, first we do that, what is the diagram of this and what is the point G? So there is the vertical line on the screen. Now there is the central bed fringes, and either side of this bed fringes here, the bed and diag fringes are obtained like this way. So there is the first order bed fringes on either side of the center. So there is the n is equal to 1, there is also n is equal to 1. Now second order bed fringes are obtained like this way. N is equal to 2. Actually n is equal to minus 2, here minus 1. Here the n is equal to minus 2 plus 2. And third bed fringes is like this. For simplicity, we show on only the thread. N is equal to minus 3. Suppose the G pointed here. We require the intensity at point G. Here, what's the one? The phase difference due to the two sources is phi at point Z. Now, according to our principle of superposition, the resultant displacement at point G is Y is equal to Y1 plus Y2. Substitute the value. Y1 is equal to A cos omega t, Y2 A cos omega t plus phi. We keep the A constant, therefore cos omega t plus cos omega t plus phi. Now how we simplify it? So using the equation of trigonometry, cos plus cos, 2 cos cos. So we are using this equation. Cos A plus cos B is equal to 2 cos A plus B by 2 into cos A minus B by 2. So that is our A, and this term is our B. Therefore, our equation becomes, here 2 is taken outside of this bracket, 2A. Now inside, cos A plus B, omega t plus I upon 2 into cos A minus B, omega t minus phi upon 2. Here omega t cancel. Here 2A. Now cos omega plus omega, 2 times omega t divided by 2, so only the omega t plus phi upon 2 into here cos minus phi by 2, cos minus phi by 2. Now we know that cos minus theta is equal to cos theta, but cos minus theta is equal to cos theta. Therefore, using this concept here, we are write down like this way: y is equal to 2A cos phi by 2 into, second term is this, cos omega t plus phi by 2, like this way. So that is the equation of resultant displacement at G. Therefore, the amplitude of the displacement at G is the amplitude of resultant displacement at G is 2A cos phi by 2. 2A cos phi by 2. And intensity at G is I proportional to the S square, amplitude square, that means the 4S square cos square phi by 2. Here is the equation number 3. So there is the intensity at point G where the phase difference between the two waves originating from the different sources S1 and S2 is phi. But we know that our original equation I0 proportional to the S square. I0 is the intensity of the each of wave. I0 is equal to intensity of each wave. Therefore, from 3 and 4, I upon I0 is equal to 4S square cos square phi by 2 upon S square. S square square cancel. Therefore, I is equal to 4I0 cos square phi by 2. Is the equation of intensity at point G. Clear this? If this equation is obeyed, so the constructive interference will be formatted for G and the intensity at point is maximum if this equation is obeyed. The constructive interference is obtained and intensity will be maximum. Intensity will be maximum at that point. So there is the equation of the intensity at this point where the phase difference between the two displacement of the two sources is high. Again we repeat it. So what's happened? Our aim is to obtain the equation of intensity if the phase difference at a point between the two sources is high. For that purpose, first we assume that suppose the phase difference at point this G between the displacement of the two sources is G. And if the displacement of the source S1 is Y1 is equal to A cos omega t, and due to the source S2 is there is the high phase ahead than the Y1, therefore A cos omega t plus phi. From principle of superposition, the resultant displacement is G, and G is Y is equal to Y1 plus Y2. But we substitute the value of Y1 by 2. So A cos omega t plus A cos omega t plus phi. A is taken common. Here we apply the equation of trigonometry cos plus cos, 2 cos cos. Therefore 2A, 2 is taken outside of this bracket, cos A plus B. That means the omega t plus phi upon 2 into cos A minus B. That means the cos omega t minus phi upon 2. So here omega t cancel. Here 2 times omega t divided by 2, only omega t plus pi by 2 into cos minus pi by 2. But we know that the cos minus theta is equal to cos theta. Therefore, our resultant displacement y is equal to 2a cos pi by 2 into cos omega t plus pi by 2. Okay. The amplitude of resultant displacement at G is, from this equation that represents the amplitude 2a cos pi by 2. And intensity at G is, we know that the intensity at any point is directly proportional to the square of amplitude. Therefore, I proportional to the square of this term. So 4s square into cos square pi by 2. But we know that the intensity of each of wave is I0 proportional to the s square. Taking the ratio of these two equations, 3 and 4, I upon I0 is equal to 4s square cos square pi by 2 upon s square cancel. Therefore, I is equal to 4I0 cos square pi by 2. If this equation is satisfied, so at G point we obtain the maximum intensity. That means the constructive interference is formed. Okay, now just we derive this equation. The intensity at point G. At that point, the phase difference between the two sources or the two displacement is phi. So the intensity at that point, I is equal to 4I0 cos square pi by 2. Okay. If this intensity is maximum, that means at this point, the constructive interference take place. Now, this intensity depends on the value of phi. Therefore, for value of phi is equal to either 0 plus or minus 2 pi plus or minus 4 pi. So this type of the value, so intensity will be maximum and constructive interference take place at point G. For value of G, for value of phi is equal to 0 plus or minus 2 pi plus or minus 4 pi and so on. The intensity at point G will be maximum and constructive interference. Constructive interference is formed. Will be formed. So there is the condition for the constructive interference, so the maximum intensity at point G. And if value of phi is equal to plus or minus pi, plus or minus 3 pi, plus or minus 5 pi, and so on, the intensity at point G is minimum. And destructive interference is formed. Therefore, which type of the interference is obtained, whatever the intensity at point G is obtained, that depends on the value of phi. Clear this point? Okay. So there is the equation of intensity at point G. At this point, the phase difference between the two waves originating from the two different sources S1 and S2 is phi. Clear this? So in short, the intensity depends on the phase difference at this point between the two waves. Clear? Okay. After that, we are going to discuss about the coherent sources and stationary interference. For that purpose, the question is that explain coherent sources and stationary interference. Already we discussed about the coherent sources. What is the coherent sources? If the two sources oscillating with the same phase, or the phase difference of their oscillation remain constant with time, such two sources are known as the coherent sources. Clear this? So first, the definition of the coherent sources: if two sources oscillating with same phase, or the phase difference between their oscillation remain constant with time, these sources are called coherent sources. Again, keep in mind that because in Young's double-slit experiment, they required the two sources must be coherent. If the two sources oscillating with the same phase, or the phase difference between their oscillation remain constant with time, so these sources are known as the coherent sources. Okay. Now the interference pattern in which the amplitude is remain constant, but the phase difference at any point remain constant with time, so such interference is known as the stationary interference. The interference pattern in which the phase difference at any point, does not change with time. Does not change with time. So this interference is known as the stationary interference. This interference is known as stationary interference. So keep in mind that the interference pattern is produced due to the superposition of the two waves. So in this pattern, at any point, if the phase difference does not change with time, right, between the two superposed waves. So whatever the interference pattern is obtained, that is known as the stationary interference. Now, in stationary interference, there should be the two coherent sources. There should be two coherent sources and the amplitude also should be same, and amplitude should also be same. So there is the condition for the stationary interference. Right? In stationary interference, what's happened? There should be the two coherent sources and the amplitude should also be the same. Now, one more point in the stationary interference. In stationary interference, the maxima and minima does not change with time. In a stationary interference, the maximum and minimum does not change with time. Because what is the reason? Because the phase difference at any point is also even constant with time, therefore does not change with time. So there is the definition of the stationary interference and also what is requirement for the stationary interference. For stationary interference, this sources must be coherent and also the oscillating with the same amplitude. While also in stationary interference, the maximum and minimum does not change with time. Again, last we discussed about the equation of intensity I is equal to 4I0 cos square pi by 2. This intensity is obtained. Okay. Here the intensity depends on the phase difference at any point. Right? The phase difference between the superposed two waves. Now for value of pi, either 0 or plus or minus 4 pi or plus or minus 4 pi and so on. The intensity at point G will be maximum and we can say that the constructive interference will be formed at that point. And if the value of pi is either plus or minus pi or plus or minus 3 pi or plus or minus 5 pi and so on, the intensity at point G is minimum and destructive interference will be formed. After that, what is the coherent source? The coherent source, that means the sources oscillating with the same phase. Already we discussed in the constructive interference, the two needles are oscillating with the same phase. Okay. And the phase difference was, the phase difference between their oscillation remain constant with time. So these sources are known as the coherent sources. So due to the coherent sources, what's happened? The interference pattern in which the phase difference at any point does not change with time. So this interference is known as the stationary interference. And also in stationary interference, the sources should be coherent and the amplitude must be same. One more thing, in stationary interference, the position of the maximum and minimum does not change with time. So that is for stationary interference. After that, we are going to discuss about what is the incoherent sources and what is the equation of the incoherent sources. Clear this? Okay. Okay, now up to this we discussed about the coherent sources and we derived the equation of intensity due to the superposition of the two waves. These two waves are produced from the coherent sources. We obtain the equation I is equal to 4I0 cos square phi by 2. Now after that we are going to discuss about the coherent sources and then what is the equation of the intensity if the two waves emanating from or the produced by the coherent sources and these two waves are superposed. So what should be the intensity at that point? For that purpose, what is the incoherent sources? When the two sources oscillating with or the phase difference of two oscillating sources rapidly changes over time. So such sources are known as the coherent sources. When the phase difference between two oscillating sources changes rapidly with time. The sources are known as incoherent sources. Incoherent sources. Now here, the intensity is added into each other. When these two sources or in the two waves of these two incoherent sources are superposed on each other. So what's happened? The intensity are continuously added into each other. The intensities is added to each other due to superposition of two waves produced from incoherent sources. So when these two waves produced from the incoherent sources are superposed, at that time the intensity is not constant. Intensity not constant, that is continuously added to each other. And due to that reason, whatever the interference pattern is obtained, that is not stationary. It's not stationary. Now after that, if the phase difference between the two waves continuously changes with time, so what's happened? The interference pattern also changes with time. If the phase difference between two sources changes with time, So what's happened? The interference pattern also changes with time. The interference pattern also changes with time. Now, when the phase difference changes very rapidly with time, at that time the position of maxima and minima also rapidly changes. And when the phase difference changes rapidly with time, the position of maximum and minimum also changes rapidly. So at that time the intensity at all the point due to this type of the interference pattern is not constant, and due to that reason we take the average intensity. Therefore, the average intensity at all points is average I is equal to 4I is the maximum value taken out, and average of cos square pi by 2. Now, if phase phi t is randomly changes randomly with time, at the time the value of cos square pi by 2, average cos square pi by 2 is approximate 1 by 2. Therefore, intensity at all points of pattern is, we can write like this way: I is equal to 4I0 average cos square pi by 2. We substitute the value of average cos square pi by 2 is equal to 4I0 into 1 by 2. So it's equal to 2I0. Therefore, intensity I is equal to 2I0 in case of incoherent sources. While in case of the coherent sources, this value is 4I0 cos square pi by 2. Clear this? So that is in case of incoherent sources. And what is the intensity? First, the definition of incoherent sources. When the phase difference between two oscillating sources changes rapidly with time or the over time, the sources are known as incoherent sources. So, what are the waves are superposed, produced from the incoherent sources and superposed? The intensities are added to each other. Therefore, and if the phase difference between the two sources changes with time, the interference pattern also changes with time. Now, when the phase difference changes rapidly with time, at that time the position of maxima and minima also changes rapidly. Therefore, the average intensity at all points is given by the equation average I is equal to 4I0 average cos square pi by 2. And if the phase phi t at any instant of time is changes randomly with time, so what's happened? The value of average term becomes the half. In this equation, cos square pi by 2 is represents the average term of time. That is represent the average term. Therefore, its value becomes the half, and intensity at all the points is obtained. I is equal to 4I0 average cos square pi by 2. Substitute the value of average term as half. Therefore, I is equal to 4I0 into 1 by 2. That means the 2I0. So there is the expression of intensity in terms of the two waves originating from the incoherent sources and superposed.